This lesson is all about cumulative frequency. So we've got a few things that we need to cover during this lesson. The first thing is to understand what cumulative frequency is all about. Once we've got that understanding, then we can draw things called cumulative frequency graphs. Now the usefulness of those is that we can, from those graphs, get an estimate for the median. If you remember what the median is, the middle number, and also something called quartiles, which you won't probably have come across before, but will become clearer later. We can then calculate another measure of spread, which is called the interquartile range. Now you've already come across the range, so you should understand what that means. That's the distance between the biggest and the smallest number in the data set, but the interquartile range is actually better. It's a better measure of spread than the range, so you'll understand why that is the case. And then there's something called a box-and-whisker plot, or just called a box plot, and that's something else we can draw using our data. So that's what we're going to cover during this lesson. So make sure you've got your maths books in front of you, write down the title, and then you should make notes as I go along through this. If you need to pause the video to copy stuff down, then feel free, but you should be writing down everything that comes up on these next slides, so you've got them as notes in your books. Okay, let's talk about cumulative frequency and what it's all about. If you think about the English definition of cumulate, it's sort of to add things up as we go along, or to add to something. So cumulative frequency is like a running total. So how you calculate it is, if you're given a frequency table, what you do is you add up the frequencies as you go along. Okay, so if you write that definition down and then make a copy of this table here. So as I said, do pause it if you need to, so just copy it down. So let's just understand the context of this table. It's some data on the results of 100 people and how long in seconds they could hold their breath for. So these two columns here, so the time in seconds, okay, and the frequency. You will have seen frequency tables like that before. That's what we did in a previous lesson. This is grouped data. Okay, so the 9 that are in that first row are 9 values between, not including 30, so bigger than 30 but less than or equal to 35. So if you remember what we talked about last time, grouping data, it's useful when you've got a large number of data items, but we have lost the individual values there, so we don't know what the values were for those 9. But it's an easier way of recording all of this data when we've got 100 individual items. Okay, so if you've copied down that table, now let's have a look what cumulative frequency is all about. So it's easy to fill in the first row. So what the first row says is the cumulative frequency is 9, so it's just the same as the frequency. And what this says is there are 9 people who could hold their breath between 30 and up to 35 seconds. Now when we go to the next row, okay, the next row we fill in a 21. Now how do we get that 21? Well, we take the 9 and we take the 12 and we add them together, and that gives us the 21. So what goes in this next column is, it says, well, there are 21 people who could hold their breath between 30 and 40 seconds. Okay, so let's do the next row. The next row is 45. What we've done there is we've done 9 plus 12 plus 24 to give us 45. You can see how it's a running total of the frequencies as we go along. So you think about what's going to be in that final column. Well, 45 people can hold their breath between 30 and 45 seconds. Okay, so let's fill in the last few. So 73, so that's our 9 plus 12 plus 24 plus 28. Those 73 people could hold their breath between 30 and 50 seconds. And then the last two rows we get 89. So 89 people, so that's all of the frequencies added up to that row. And 89 people could hold their breath between 30 and 55 seconds. And the final one is 100 people between 30 and 60 seconds. Now, it's always useful to have a little check just to make sure that you've not made a mistake with your adding up. So do always make sure the last number here that you get in your cumulative frequency column, that should be the same as the number of people in total that were involved in your survey or in your results. So do double check that that all adds up. Okay, so that's calculating the cumulative frequency. So what we're going to do now is we're going to make use of that and put it on a cumulative frequency graph. So on to the next slide. Now I've got my table up in my top right hand corner there, just so we can see what we're doing. Okay, so a few important things to note then. First thing, cumulative frequency always goes on the y-axis, so it always goes vertically upwards. Okay, now our range of values for cumulative frequency go between 0 and 100, so that's what your scale needs to be for that. What goes along the other axis is whatever those data items are measuring. So in this particular example, we are measuring the time people could hold their breath in seconds. Now, this is a graph I got from somewhere else. If I had drawn this, I would have here put in one of those little zigzags just to say that that doesn't start at 0. So that's what I would do. Okay, right, now here's the really important thing that you need to remember. We need to plot these cumulative frequency values here. And the question is, where do we plot it? Now, if you remember, the right-hand column on our previous table said that those 9 people could hold their breath in a time between 30 and 35, so up to 35 seconds. So this value here, this 35, okay, which is the upper end of my interval, that is where I plot the 9. So this is the most important thing for you to remember. You must plot your cumulative frequency at the upper boundary for the class interval. So the 9 will be plotted at 35, the 21 will be plotted at 40, reason being 21 people could hold their breath for up to 40 seconds. The 45 will be plotted at 45, etc, etc. Okay, so you should do pause if you need to, you should draw that graph into your book, make it a decent size, because in a moment we're going to be reading some values off it. So I would say make it at least half a page in your book. Okay, so if you need to pause it while you do that, please do. So let's see how we plot these values then. This plots them on there for you. Okay, so notice the 9 is plotted at 35, the 21 is plotted at 40, okay, the 45 is plotted at 45, etc, etc. And they have done, right down at the bottom here, they have plotted 0 at 30, because there was nobody that held their breath for less than 30 seconds. Okay, so we've plotted our values. When I plot them, I would usually use a cross rather than a dot. Okay, now we can join them up. Right, now on this particular example here, they've joined it with a smooth curve. Now, it is acceptable to join them with straight lines, and personally that's what I always do. I join them with straight lines because you're allowed to do that, and it just means that you can use a ruler to be nice and accurate between the points, especially if they're a little bit of a distance apart, and I think that gives a better graph that you can read values from. So you can do either a curve or straight lines, but as I said, I prefer to do straight lines. Okay, so this is your cumulative frequency graph. That's what it looks like. Important things to remember: cumulative frequency on the y-axis, you plot the values at the end of the interval, so at the end, that's really important. Okay, now we mentioned that we can read the median of the cumulative frequency graph. Now remember what the median is all about. The median is the middle value once I have put them all in order. Okay. We know there are 100 people that took part in this survey. So the middle value is going to be the 50th one. Now these are already in order because they're grouped in the intervals which are in order. So if I want to find the 50th one, what I can do is find where 50 is on my cumulative frequency axis here, and I can draw a line across, okay, and a line down, and I can read my value off. Now when you're reading these values off, do draw the lines onto your graph. The examiner will be looking at where you've read your value from, and obviously because it's read from a graph there will be a little bit of tolerance for errors here, and if you've drawn your line on and your graph is correct, then as long as you've read your value according to the scale correctly, you will get the marks for it. So draw it onto your graph, okay, when you read it off from the bottom axis here, okay, it gives you 47 seconds. Now, like I said, if you've got 46, if you've got 48, that would be fine. Okay, right, so that's how you read off the median. So make sure you're happy with that. Make sure you've got all of that written down in your books as an example. If not, pause it. Okay, right, let's go on now to talk about the interquartile range, because we can also read that off a cumulative frequency graph. Okay, so again, if you write all of this down, it's a useful thing for you to have in your notes. Right, just a quick reminder then, the range is a measure of spread. So it tells you how varied the data is, how spread out the data is. How you calculate the range is you do the difference between the biggest value and the smallest value. Now, if I was to ask you, if we were in a class together and I was to ask you what are the problems with the range, hopefully you would think, right, well, I can get quite a big value if my data contains things called outliers. If you remember what outliers are extreme values. So if I was to say gather a lot of data about the heights of different pupils, the outliers would be the really, really tall pupils or the really, really short pupils. And that can affect your range because it takes into account all of the data. So what we can do to sort of get by from that is we can calculate something called the interquartile range. Okay, so what the interquartile range is it says how spread out is the middle 50% of the data. So if I ignore the smallest 25% of values, the biggest 25% of values, then how spread out is the middle 50%. Now that's going to be more useful than the range, because if I do have any outliers, by ignoring the 25% smallest and 25% biggest values, I will have ignored those outliers. Okay, so how we calculate the interquartile range is using our graph, we will read off something called the lower quartile. Okay, remember when we read the median, we went halfway up the cumulative frequency axis and went across and down. So to read the lower quartile, we will do the same thing, but we will go a quarter of the way up the cumulative frequency axis. Okay, and then we read the upper quartile as well. And the upper quartile is 3/4 of the way up the cumulative frequency axis. And again, we draw a line across and drop it down. And then the interquartile range is basically the difference between the upper quartile and the lower quartile. So when you're calculating it, all of these things, you will draw your lines on your graph, you will write down your values, and you will calculate it and show all of your working. Okay, so make sure you've got that all written down in your notes. What we're going to do now is we're going to go back to our graph that we had before. So we're going to use the same graph to do with the how long people held their breath for, and we're going to read off the lower quartile and the upper quartile from this. Okay, right, so remember, lower quartile, that's a quarter of the way up the total number of people. So that's going to be 25 on the cumulative frequency axis. So on your graph, draw your line across at 25, drop it down. You should get something around 42 seconds. Again, it may be a little bit more, it may be a little bit less, but that's fine. So that's your lower quartile. Upper quartile, that's 3/4 of the way up. Okay, so we're going to draw a line across at 75 and we're going to drop it down. Do it on your graph. You should get roughly 51 seconds. Okay, and then to calculate the interquartile range, what we do is we do the difference between the lower quartile and the upper quartile. So make sure you state both of these. I quite often call this just LQ. So my lower quartile is 42. Okay, and I quite often call this UQ, upper quartile is 51. Okay, and then when I calculate the interquartile range, again, I usually call that IQR for short. My interquartile range, show the values you've used, 51 minus 42, which is 9. Your graph, if you've got these values slightly differently, you will get slightly different values, but it should be roughly that. Now, just make sure you understand what's gone on here. 9 seconds is the range of values of the middle 50% of the data. So you can see what we've done is we've ignored the smallest 25% and we've ignored the biggest 25%. Okay, so this tells you how spread out the middle 50% of the data is. So it's a more useful measure than the range because it ignores the very small and the very big values. Okay, right, hopefully that's all clear to you. So final thing we're going to have a look at is something called box plots. Okay, so when we have a set of data, there are 5 key statistics that we can calculate for that data, and these can all be read from our cumulative frequency graph, or the majority of them. Okay, so the 5 set pieces of data that we're going to use to draw our box plot are, first one, median. Okay, we know how to find the median. So the median is the middle number, and what we do is we use our cumulative frequency graph and we go, what I mean by half n. N is the number of data items. So in our time to hold your breath, we had 100 data items, so we read across and down at 50. So median is the first key statistic. Lower quartile, remember how we read that? 1/4 of the way up through the data, or LQ. The upper quartile, 3/4 of the way up through the data. So that's 3 of them. Now the other 2, okay, are the smallest value that's within your set of data and the largest value within your set of data. Now, sometimes questions will specifically mention what was the smallest value and what was the largest value. If they don't, then what you will need to use is you will need to use the smallest bound of the first interval. So for example, with our breaths, it was 30. And the largest one, you would need to use the upper bound of the biggest interval. So if you remember with our holding our breaths, that would be 60. But as I said, sometimes they specifically give you those values. Right, let's have a look how we draw those on something called its full name is a box and whisker diagram. So when you're asked to draw these in a question, they may call it its full name, box and whisker diagram, or they may just say box plot. So make sure you're happy with both of those terms. Now, when you draw your box plot, you will need a scale to draw it against. If you've already drawn your cumulative frequency diagram, then you can draw it underneath that using the same x-axis scale that you use for your cumulative frequency diagram. If you haven't, then you will need to use a scale to draw it against. So let's have a look what a box and whisker diagram looks like. Remember, it's going to have on it those 5 key statistics. Okay, right. The box is drawn to go from the lower quartile to the upper quartile. So in our question, the lower quartile was 42, upper quartile was 51. So that makes the length of your box. So if you think about it, the length of your box is actually your interquartile range. So if you have a bigger box, it tells you that the data, the middle 50% of the data is more spread out. If it's smaller, it tells you it's more close together. Okay, so that's the box. Now the median, what you do is you draw the median as a vertical line within the box. Okay, so our median was 47, so that makes our box with the median in the middle. Now that's box. I've said it's a box and whisker diagram, so let's see what the whiskers are all about. Okay, so the whisker on the left-hand side goes right down to the minimum value. So for our holding our breath, the minimum value was 30, so we draw a whisker out to 30, and then the right-hand side whisker goes out to the maximum value. So that shows you from the minimum to the maximum, the whole thing with the box and the whiskers shows you the range, whereas the box shows you the interquartile range. Okay, so that is what your box and whisker diagram looks like. As you can see, we need a scale along the bottom, okay, on which we record our values, and that is what it looks like. Okay, right, let's see and make sure you do that. So what I want you to do now is I want you to basically, in your books, probably starting a fresh page, I would say, I want you to copy down that table. So context of this question, it's the weight of 120 pupils, goes from 0 up to 100 kilograms. Here's my frequency values. So what I want you to do is copy that table. They've started filling in the cumulative frequencies. They've done 8, they've done 49, which is 8 plus 41. So I want you to fill in the rest of those. I then want you to draw a decent pair of axes. So remember, the cumulative frequency goes on the y-axis. That will need to go up to 120 because there are 120 pupils. And the x-axis will have the weight, and the weight will go from 0 to 100. So I would like you to draw that. Onto your axes, you are going to plot your cumulative frequency. Just as a reminder, you plot the 8 at the top end of the interval. So that plots at 20. You plot the 49 at 40, etc. So you do those with crosses. I'd recommend getting a ruler and joining them together with a straight line. Okay. Once you've done that, I want you to read off the median. That's halfway through the data. So if there's 120 pupils, think about what half of that is. I want you to read off the lower quartile and the upper quartile. So remember, the lower quartile is a quarter of the way up the data. So if there's 120, what's a quarter of the way up there? And the upper quartile is 3/4 of the way up. And then that will enable you to calculate the interquartile range. Okay. And then once you've got that, I want you to draw a box plot. Now you can draw the box plot underneath your cumulative frequency graph, so using the same x-axis scale. So remember, the box goes from the lower quartile here, oops, sorry, that's a bit bad, the lower quartile here, upper quartile here, the median is the line, and then remember where your whiskers go out to the biggest and the smallest values. They haven't been specified specifically in the question, so the smallest weight will have to be the lowest value possible in the range, and the biggest one will have to be the biggest one in the range. Okay, so I want you to do all of that. Now the last part of the question then. Okay, last part of the question. You use the graph to find out how many pupils weigh between 30 and 50. So I've got my graph drawn with my weight along here, my cumulative frequency up here. My graph is going to look something like that. How many pupils weigh between 30 and 50? Okay, we'll have a little think. I've got 30 and 50 on my scales here somewhere. So if I want to know how many are between those, well, let's go up and across, and let's go up and across, and it's going to be whatever number of people are in that range. Okay, so pause this now, get that all done, and then in a moment my worked answer is going to pop up on the screen, but please do pause it and have a go at that yourself. It will show whether you've understood this. If as a result you don't, or you're not sure, then just go back and watch some other video again. Okay. Right, here is my worked solution. So check your answers against here. Make sure your cumulative frequencies are all right, that are filled into the table. Here's my graph. Can you see I've joined them with straight lines because I prefer to do that. I find that easier. I've read off my median as 44. I've read off my lower quartile as 30. My upper quartile is 55, so my interquartile range is 25. There's my box plot. Can you see how with my box plot I've drawn it underneath the axis, so I haven't had to draw another set of axes. The whiskers go from 0 to 100. Here's my median at 44. Here's my lower quartile and upper quartile. And then this part here, just make sure you've understood how to do that. What I've done to work out how many people's way between 30 and 50, I've gone up from 30 on my x-axis. Now actually, that's my lower quartile, so I've already got that line drawn on. So the cumulative frequency for 30 kilograms is 30. And then I've drawn the dash line here at 50, and the cumulative frequency I read off as 76. So between those two values, there are 46 pupils. Okay, so hopefully you've understood all of that. Right, over to you now. Here are some questions that I would like you to complete. Okay, so it's in your textbook, 16.2s, questions 3 and 4. So I would suggest in your exercise books, okay, that you do one question on each page. So take a whole page to write out the table, to draw your cumulative frequency graph, to work out your median, to work out your upper and lower quartiles, draw the box plot underneath it, just like we did in that previous example. And then the final parts of the questions are sort of reading off some values like we did in that example together. So I want you to do questions 3 and 4 and make sure you are happy with those. Okay, now I'm not going to ask you to submit any of this work. Your work on Wednesday, okay, is going to be some My Maths, so I will be able to see your results from that. If you have any problems though, okay, please do drop me or your teacher an email, okay, and they'll be able to help you with that. So as I said, if there's anything you don't understand on this, just go rewind and watch the video again. Otherwise, good luck with that.